Derivatives of sine x and cos x. Sine x and cos x are two functions which have easy to remember derivative rules. These derivative rules are that the derivative of sine x is cos x and the derivative of cos x is negative sine x. These rules are nice and simple, they're easy to remember. The only confusion people sometimes get with them is forgetting which one is positive and which one is negative. However, these rules only work if we're working in radians. If we're doing some problem in which we're using degrees, the derivative rules turn out to be much more complicated in that sort of situation. So, if we've got a problem using degrees, we need to solve a problem involving degrees, and we're trying to use calculus to solve it. Before we can solve the problem, we need to convert the function in question into radians, and then approach solving the problem. So, just to see how these derivative rules work, let's try to find the derivative of the function 3 sine x minus 7 cos x. Well, when we do this derivative, the first rule we're going to use is the difference rule. We can take the derivative of the first term, 3 sine x, and the derivative of the second term, 7 cos x, separately. Then we can use the constant multiple rule, and we can pull the 3 and the 7 out. So we're going to have 3 times the derivative of sine x minus 7 times the derivative of cos x. The derivative of sine x is cos x, and the derivative of cos x is negative sine x. So in the end, this gives you 3 cos x plus 7 sine x. Higher derivatives of sine x and cos x. One of the nice things about the sine and cosine derivative rules is that if we start taking higher derivatives, we in fact get a pattern. For example, if our original function is sine x here, if we take the first derivative, we get cos x. If we take the second derivative, the derivative of cos x is negative sine x. If we take the third derivative, this negative sign is going to stay in front as a constant, and the derivative of sine x is going to be cos x. If we take the fourth derivative, the negative sign is going to stay in front. The derivative of cos x is negative sine x. Those two negative signs cancel to give us sine x. Similarly, this pattern is going to continue. The fifth derivative is going to be cos x. The sixth derivative is going to be negative sine x. The seventh derivative is going to be negative cos x. The eighth derivative is going to be sine x. It turns out that every single derivative, which is a multiple of 4, basically the fourth derivative of the 8th, the 12th, the 16th, the 20th, the 400th, all those derivatives are going to be the same as the original function. This pattern applies similarly to cos x. If we wanted to take the 128th derivative of cos x, that would also be just cos x. Every derivative which is a multiple of 4 is the same as the original function. This pattern can be used to find, for example, the 62nd derivative of sine x. So the idea here is we're starting with the function f of x is sine x, and we want to find the 62nd derivative. Well, 60 is a multiple of 4. So we know the 60th derivative is the same as the original function. It's sine x. And if we want to take the 61st derivative, well, we've got to take the derivative of sine x. The derivative of sine x is cos x. And so if we want to take the 62nd derivative, we've got to take the derivative of that cos x. The derivative of cos x is negative sine x. So the 62nd derivative of sine x is negative sine x.